We are still on the concept of height and distances, which involves the application of angles of elevation and depression. The question says the feet of two vertical poles of height 3 meter and 7 meter are in line with a point P on the ground. It says the smaller pole being between the taller pole and P. Okay, so we'll take that. First, we'll take the ground level. Okay, so we are told that the feet of two vertical poles are in line with the point P on the ground. Then it says the smaller pole is between the taller pole and P. So if we say this is the taller pole, let's assume that the taller pole is here and this point is point P. Let's assume that this point is point P. Then this is the smaller pole. Okay, the smaller pole, and the height of the smaller pole is 3 meters. The height of the taller pole is 7 meters. Okay, and it says the smaller pole being between the taller pole and P, and at a distance of 20 meters from P. Distance between the smaller pole and P is 20 meters. Okay, it's 20 meters. And then it says the angle of elevation of the top T of the taller pole. The top of the taller pole is T. That is this top here. This top is T. And the angle of elevation of the top T of the taller pole from the top arrow of the smaller pole. The top of the smaller pole, its top is arrow. Okay, so angle of elevation of T, we extend it down from arrow. The angle of elevation of T from arrow is 30 degrees. It says the angle of elevation of the top T of the taller pole from the top arrow of the smaller pole is 30 degrees. So T from arrow is 30 degrees. Now it says we should find the distance RT. So to look for distance RT is unknown. And then the next it says find the distance of the foot of the taller pole from P. Distance, the foot of the taller pole. This is the foot of the taller pole. You can call this foot X from point P. So we are going to look for this distance from here to here. Is unknown. Now we can assume that the bottom side of arrow is Y. So distance between X and Y is small y. So if this is small y in meters, that means distance from X to P will be Y plus 20. Okay, that is Y plus 20 in meters. Alright, so that's distance from here to here. From here to here is Y, and from Y to P is 20. Okay, so take note of that. And then they also say we should find the angles of elevation of T from P to the nearest degree. Angles of elevation of T from P. Okay, so I can do that now. If I extend it, the angles of elevation of T from P, call that theta. Call that angle theta. So we look for the angle of elevation of T from P to the nearest degree. Okay, so this is the diagram we're having. If I extend this line here, let's assume I'm using dotted lines, and I extend it over to this point. I can choose to call this point M. Okay, so if from here to here is Y, and that means that from here to here is also Y. So if from X to capital Y is this, is Y. That means from M to R is also Y. I can then cut out the triangle, which is 90 degrees. I can cut out the triangle TMR. If I section it out, I'll be having, so from TMR, This is T, M, and R. Okay, at point T, this is 90 degrees, and this distance is distance RT, and then this angle here is 30 degrees as the angle of elevation of the top T from point R. Distance MR is Y. Distance MR is Y. And of course, we should be able to obtain distance TM. Let's go back to the diagram, the main diagram, distance TM diagram. If the distance from here, okay, so if the distance from R to Y is 3 meters, that means that from M to X is also 3 meters. Okay, this is also 3 meters. So 7 from here to here is 7. 7 minus 3, this side will be 4. Okay, so that is 4 meters. So we have gotten that. So we have here as 4 meters. Alright, we have there as 4 meters. So the side that faces the angle of inclination is my opposite side. The longest side facing 90 degrees is the hypotenuse. The remaining side becomes the adjacent. So I'm having that. Using my trig ratios, I take opposite over adjacent, I can find y. You say tan 30 degrees will be equals to the opposite side over the adjacent side. Take note, the trigonometric ratios are so So what I'm using now is this. So tangent of an angle is equals to the opposite side divided by the adjacent side. So it means that tan 30 will be the opposite divided by the adjacent. And the opposite there is Tm. Tm is opposite. Tm is opposite over the adjacent side is Mr over Mr, which is Tm is 4 and Mr is y. So Tm is 4 and Mr is y. So we'll be having 4 over y. If I then cross multiply, this should multiply this. So I have y tan 30 degrees equals to 4. Divide by the coefficient of y. Y will be equals to 4 divided by tan 30. Okay. So y will be 4 divided by tan 30. That's divided by this. And this will be equal to 4 divided by tan 30 on my calculator is. That gives me 0.5774. Okay. That's tan 30. Then if I divide it, that gives me y equals to 6.928, approximately 6.928 to 3 decimal places. So that's why. Then I can then look for RT. If I use the opposite and the hypotenuse, I can look for RT. I say opposite of hypotenuse is so. So now I'm going to make use of so. So it means that sine 30 degrees will be the opposite side over the hypotenuse side, and the opposite side there is distance Tm. Distance Tm is the opposite side. My hypotenuse is RT. It's RT, which is equal to Tm. Distance Tm is 4. And RT is unknown, distance RT is unknown. If I cross multiply, I'll be having RT sine 30 degrees is equals to 4. So when I cross multiply this, we multiply this, I'll have RT sine 30 degrees. So RT alone, distance RT will be equals to 4 divided by sine 30. Okay, 4 divided by sine 30, and sine 30 is 0.5, so that is 4 divided by 0.5, which will give me RT will be equals to 8. So RT is equals to 8 meters. Okay, Okay, so distance RT has been gotten as 8 meters. So therefore distance RT is equals to 8 meters. Distance RT is equals to 8 meters. Okay, so take note of that. Alright. The next thing they say we should solve is the distance of the foot of the taller pole from P, correct to 3 significant figures. Okay, so the distance of the foot of the taller pole is point X from P. So that distance is distance XP. Distance XP is XY plus YP. Okay, so take note of that. So we have that distance XP is equals to XY plus YP. And you say that distance XP will be equals to XY is small y and XP is 20 meters. However, we obtain small y as 6.928. This is 6.928 meters plus 20 meters. And that gives us 26.928 meters. And they say we should solve that to 3 significant figures. So take the answer correctly to 3 significant figures. So this now to 3SF, this is 1, 2SF, 3SF, isn't it? And you cannot approximate 2 to 9. So this now will be approximately 26.9 meters to 3 significant figures. That is distance XP, which is the distance of the foot of the taller pole from point P. That is 26.9 meters. And let's look at the next thing they say we should solve there. Okay, the next thing they say we should solve is the angles of elevation of T from P to the nearest degree. Angle of elevation of T from P. So what you are going to take is this foot triangle. Taking the foot triangle TXP, triangle TXP or TPX. We say from triangle TPX. From triangle TPX, that is triangle TPX. Okay, I'll be having from triangle TPX. I'll have something like this. Here is theta, here is point T, here is P, and here is X. This is 90 degrees. Distance from X to P, we had it as 26.9 meters to 3 significant figures, and the distance TX is 7 meters. That is distance TX from T to X, 7 meters. Okay, so XP is 26.9 meters. Now what we're asked to look for is this. Because we know the value of RT. Okay, so we don't need RT in this case. Okay. Now the side facing this angle is my hypotenuse side. Okay. The side facing the angle of inclination. This side facing the angle of inclination is my opposite side. The opposite side. And this remaining side becomes my adjacent. Because my adjacent side. So I will then take the tangent of this angle since I'm giving opposite and adjacent. So that would be, so I'll have that tan theta is the opposite side over the adjacent, and the opposite side in that diagram is TX. The adjacent side is XP. So TX there is 7 meters and XP is 26.9. So when I divide them, I have that tan theta is equals to, when I divide 7 divided by 26. This is 0.2602. Okay, and theta will be equals to tan inverse of 0.2602. So my theta will be equal to, check the tan inverse of 0.2602, that will be, and this becomes 14.58 degrees. And then they said we should take that to the nearest degree. Take this, it says angles of elevation of t from P to the nearest degree. Okay, to the nearest degree. This then becomes, you approximate to the nearest degree, you have that theta is approximately 15 degrees to nearest degree. Okay, so you should know about approximation that numbers from 0 to 4 cannot be approximated. So you round them down to 0, and from 5 to 9 can be approximated. You round them up to 1, take 1, and then that's it. You see that this is 5, right? You can approximate 5 to 4, take 1 from 5, add here. This becomes 15 degrees to the nearest whole number. 15 degrees to the nearest whole number, or nearest degree. Okay, so that is it. Alright, we'll stop here for today. Thank you. Once again, I am Prosper Nnodi, and this is Mathematics Made Easy. We are solving questions today on heights and distance, which involves angles of elevation and depression. Thank you.